There are some trigonometric identities which are kind of nice and which show up a lot. One of them is called the Pythagorean identity, because if you have a circle, the unit circle for instance, and this distance is 1, these two side angles are, these two sides are cosine theta and sine theta. So one thing that's true is that sine squared theta plus cosine squared theta equals 1. That's the Pythagorean theorem. This side squared plus this side squared equals this side squared. So if you see something like this, sine squared 12 plus cosine squared 12, it doesn't really matter what's in that theta, what's in that 12. The 12 doesn't matter. This is always going to equal exactly 1. Now there's a way to take this identity and alter it a little bit. You could take each of these things right here, and you could divide by, let me get the glare off there, you could divide by cosine squared theta. And then what you'd have is sine squared theta over cosine squared theta. Sorry, that pen's not working out too well. Let me try to focus that real fast. See if that color can come back in a little better. Sorry about the blurriness. There we go, it's a little better. So if you divide by cosine squared theta, sine squared theta over cosine squared theta is the same as tangent squared theta. Cosine squared theta over cosine squared theta is the same as 1. And 1 over cosine squared theta is the same as secant squared theta. So this is a second Pythagorean identity. I could rewrite that to say tangent squared theta minus secant squared theta equals 1. And you see something that works right here. It doesn't really matter that the 4 thetas are there. If I've got tangent squared of the same thing minus secant squared of the same thing, this equals 1. So this equals 1 as well. And you may have guessed it, if I take this same formula, the Pythagorean identity, sine squared theta plus cosine squared theta equals 1, and now instead of dividing by cosine squared theta, but divide by sine squared theta, I'll get my third identity, which says, well, this is sine squared theta over sine squared theta is 1. Cosine squared theta over sine squared theta is cotangent squared theta. And 1 over sine squared theta is cosecant squared theta. And again, I can work this however I like, but if I take this cotangent squared theta and subtract off this cosecant squared theta, I'll be left with this. I'll bring it to the other side. This should be a negative 1. I guess this one should have been a negative 1 as well, so I'll put a negative 1 right there. You probably saw that when I did that initially, but I'm subtracting 1 from both sides, so that should be a negative 1 here. This should be a negative 1 here. So these three identities, this original Pythagorean identity, this one with tangent squared theta and secant squared theta, and this one with cotangent squared theta and cosecant squared theta, are three that show up pretty often.